Assalamualaikum and hi, we are from group number 9 for engineering statistics. My name is Nufazila Shafika binti Muhammad Sofyan.
My name is Muhammad Reza Irfan Muhammad Rezaudin.
And my name is Nura Amirul bin Anwar.
And my name is Muhammad Hafiz Bimanso.
So today our topic is about the electric motor temperature. So for the introduction, our purpose project is to improve efficiency, reliability, and also longevity through a focused analysis by harnessing relevant information gathered during the process. And we hope to offer significant contributions toward this parameter in motorized applications. In this project, we have two variables which are independent variable and also dependent variable. The relationship between the x-axis and also y-axis will be either linear, curvilinear, strong, weak, or no relation. Depends on the scatter plot that we get after plotting the data in the software. By doing this task, we could get the scatter plot, evaluate the regression model, person correlation coefficient, hypothesis testing, manual calculation of minimum, maximum, mean, and also standard deviation. For the data requirement, a sample of 30 data value for the electric motor temperature has been taken from the Kaggle website, has been created by Professor Dr. Ingwachim Boker of Paderborn University. The data originates from the year of 2022. Um, the value of motor temperature is taken randomly, which the range is selected as from negative 18.29 Celsius to 32.077 Celsius. And then, as shown as below, is the data and also the source link that we get. We have basically we have put the temperature and motor speed value in the table, and moreover, the independent variable is the speed of an electric motor. Is the independent variable because it can be controlled directly, while the dependent variable is a starter widely temperature because it's affected by the speed of the motor. As the speed increase, the temperature motor will be increased. This is because the faster the motor spin, it will get more heat it generates. Next, for the manual calculation.
Okay, for the manual calculation, I will show the manual calculation. Okay, this is the total sum of X bar for variance, means, and variance temperature of the motor. And the final answer we will get for X bar is 25.1112. And for standard deviation, the total sum we get is 671.2793. And secondly, the manual calculation for mean and variance for motor RPM, X bar will we get is 291.3034, and for standard deviation we get 124,55027.03. Okay, according to the data, minimum of X, which is motor speed, is 0.003, while the maximum is 4998.26, and the minimum of Y, which is temperature, is 19.29 Celsius, while the maximum is 32.0779 Celsius. Okay, next, for demonstration simulation. Reza, go.
Okay, so I'm gonna continue for the software simulation. So this one I am using the Excel. This I already put the input for X, this one, motor speed, and also the Y, this temperature. And then a summary for those for both data for motor speed and temperature by using this data analysis correlation. And then after that, I use this data to find the linear regression and plotting for this graph. Just insert the graph and put the data. I already put it has this highlight for S and Y. And then continue for the calculation for S, the sum of S square. I'm just using the command for each of this value. But for example, this one sum SQ, so this was square root, sum of square root. This one sum of SY, and also continue with this SSY, SSS, and also until got the R. So this calculation also same as result for both X and Y. This one summary output for regression statistic. This is R square, so it's R. So it's same as the this value. Okay, same also with the residual output and probability output. So this is the result for the graph. Here you can see we said that this the data is linear, and also same as for the temperature. Okay, so for the hypothesis testing here, we put this our test here, put the calculation when there's both alpha 0.01 and also 0.05. So this is the result for the t-test, and our t-test we already test here the conclusion. Also for the said that enough evidence to support the claim. Okay, so this analysis for the result. So you can say that our data is mostly uh, strong linear relationship because of the our R is nearly to the one and not to negative. So this can be strong relationship for linear. Okay, that's all for me. Thank you. 3.
Okay. As a conclusion, in this segment, we need to find the relationship between dependent and independent variable, which is the dependent variable is speed of motor and independent variable is a temperature. Refer to the data, we can find the minimum and maximum, which is x and y. For the x is value of the speed motor and y is the temperature of motor. So the maximum of x is 4998.26 and the minimum is 0.03. And the maximum of y is 32.009 and the minimum is 18.29 Celsius. So for the observation, we get the graph is the relationship is positive strong, which is slightly to 0, slightly to 1, and our value is 0.914. That's all. Thank you.
Thank you.